Hello, in this video I'm going to be showing you how a derivative is defined. First, we're going to graph a linear function x plus 1. F of x equals x plus 1. We graph that, it's going to look something like that. We know that our slope is the rise over the run, or the change in y over the change in x. It can also be rewritten as y2 minus y1 over x2 minus x1. So if we pick 2 points on this line, we can use our definition of our slope to come up with the slope. So it would be 1 minus 0 over 0 minus negative 1, 1 over 1, 1. So the slope between these 2 points is 1. In fact, the slope anywhere on this line is 1 because it is a linear function. Let's take a look at a nonlinear function. We graph that. It looks something like this. Now, the slope here is different than the slope here, which is different from the slope here. At any point on this curve, the slope is going to be different. So it becomes more difficult for us to come up with the slope. So if I want to know the slope here, I can estimate it by picking, let's pick 2 points on the line. I can estimate that the slope here is close to the slope between these 2 points. So 2 points here, and we use our slope formula to come up with the slope. So we can estimate that the slope at this point is going to be 2 using these 2 points. I'm going to redraw it. We're still looking for the slope at that point. Over here we picked these 2 points. If we move a little bit closer, and we draw a line to estimate the slope, it's going to be more accurate. In fact, the closer we get with these 2 points to this point, the more accurate the slope is going to be. So let's arbitrarily call this point x, and when we put x into the function, we will have f of x. If we move over h units, we'll get this point right here, x plus h. We moved over h units. And if we substitute x plus h into our function, we have f of x plus h. So now we did the same thing. We took 2 points, but we arbitrarily define those 2 points in terms of x and h. And we're going to do the same thing. We're going to plug that into our slope formula. So we have y2 minus our y1 divided by our x2 minus our x1. Our x's on the bottom cancel, and we're left with this. And h represents the distance between the 2 points. So as we get closer and closer together, this h value gets smaller and smaller. And it'll get smaller to the point where it equals 0. And when it equals 0, that means we are exactly on the point where we wanted the slope. So we say is the limit as this h value gets closer and closer to 0, as it approaches 0, we can get the slope at any x value on the line. And this is our fundamental definition of a derivative. I hope this video was helpful, and thanks for watching.